One more thought experiment. Again, I won't tell you the details, but you can look them up in any book on special relativity. This time, the conclusion of the thought experiment is that moving clocks run slow. Not anything wrong with the clock, of course. You can have a defective clock, but that's not what we're talking about. Perfectly good clock, but if it's in motion, then it runs slow relative to somebody that's at rest. We call this time dilation. Again, the factor is gamma, that same factor gamma. So, but this time it's the other way up. T is equal to gamma times T0. So if this is a time interval as measured on the train, this is the same time interval as measured on the ground. But it's a factor of gamma off. So what does this mean, actually? Suppose that here you are on the train, and you got a big old clock, so that it's easy for me to read from the outside through the window. So there's the clock, and it's whatever it is. And you on the train and me on the ground. Here's me on the ground. And I have with me a watch. And you have a clock. I say, Amber, your clock is running slow. My clock ticked off 15 minutes, and yours only ticked off 10 minutes. So it's running slow. That's what I mean by saying the clock is running slow. Should have ticked off 15 minutes, only ticked off 10, it's running slow. Of course, we encounter exactly the same problem as before. From your perspective, it's I who am moving in the opposite direction at the same speed. So you say, on the contrary, David, your watch is running slow and my clock is perfectly fine. Who's right? Is your clock running slow, or is my watch running slow? Answer, we're both right. How can that possibly be? If your clock is running too slow, you should have concluded that my watch is running too fast, but you didn't. You came to. So how can it possibly be that we are both right? Well, once again, you have to study very carefully what it means to measure the rate of a clock, especially a moving clock. So let's watch what I actually did when I concluded that your clock was running slow. Here's your clock, and it's on the train that's going along at speed v. And when it passed me, I recorded the time that your clock said, and I also recorded at the same moment the time that my watch recorded. So I have your time and my time. Meanwhile, the train has moved over to the right, of course, and now your clock reads some later time. And since I'm not over there, I've got an assistant who's stationed right here and has his own watch. And I tell my assistant, would you please read the reading on the big clock as it passes you by, and at the same time, read the time on your watch. And then we're going to subtract the 2 times we got on your clock, and subtract the 2 times we got on our watches, and we conclude that the time elapsed on your clock was too small. That's what we mean by saying that your clock was running slow, that the elapsed time on our watches, the difference of the two watch times, was a larger number than the difference of the two clock times. The moving clock is running slow. But notice how I made this measurement. I was obliged to compare one and the same clock of yours, the big clock on the train, to two different watches of ours, mine and my assistant, who was stationed down the track to be right there when you passed by. I had to compare one moving clock, to two different stationary clocks. Now, from my perspective, that's perfectly okay, because of course we synchronized our watches. Well, what does that mean, to synchronize the watches? It means that at 12 noon, or whatever was the magic signal that we chose, I set mine to 12 noon, and you also set yours to 12 noon, and that's what I mean by saying that the two watches were synchronized. But of course, that means that I had to set them to 12 noon simultaneously, at the same instant. You, riding on the train, looking at me, watching what I did, said, you used two different watches here, and those two watches were never synchronized in the first place. So no wonder you got the wrong answer when you were looking at the rate of my clock. You used two different watches, both of which were running too slow by this same factor gamma. Both of them were running too slow, but they weren't even synchronized in the first place, because to synchronize two watches means to set them to 12 noon simultaneously, and you and I disagree about simultaneity. Of course, watching you measure my watch, remember you concluded that my watches were running too slow, you made exactly the same silly blunder. You used two different clocks of yours, and according to me, they were not synchronized in the first place. So each of us makes a very elementary blunder from the other one's perspective, namely, we used watches that were not synchronized in the first place, or clocks that were not synchronized in the first place. So of course we got the wrong answer. That's how I managed to conclude that your clock was running slow, and you managed to conclude that my watches were running slow, and both of us were right.